Hi everyone. So today we are going to do a lesson on monomial and polynomial functions. And so we're going to do a little review. We're basically just kind of defining what monomials and polynomials are, as well as doing a couple of basic operations like addition, subtraction, multiplication, and division. Okay, so let's start with the definition of a monomial. So a monomial is a number, variable, or a product of numbers and variables. So a monomial example would be something like 3x cubed, right? You could even have something like 2a squared b to the third, right? It's a single term, right? You could even have like a product of them. So you could have negative 8a squared times x to the fourth, something like that, which we could simplify as negative 8a squared x to the fourth. Okay, so what we're going to do in the next set of examples is we're going to use some exponent rules to help us simplify monomial expressions. We did this way back in Unit 1. We're just kind of doing a little bit of a refresher. Okay, so let's take a look at example 1. We have 5x squared times negative 7x to the 6th. So remember, we can multiply the numbers together. So 5 times negative 7, we get negative 35. X squared times x to the 6th. Remember, when you multiply exponents that have the same base, we add the exponents. So we're actually using this rule. X to the a times x to the b equals x to the a plus b. So if you want to have that rule written down in your notes, it might be useful. So we're going to do x to the second plus 6, which would be negative 35x to the 8th. And that would be a fully simplified monomial. Okay, let's get into one that's a little bit more complicated. Let's take a look at number 3. So we have 2/3 r squared s to the 7th, all squared in parentheses, times 1/6 r cubed s. So remember, order of operations still apply here. So the first thing that you want to do is actually do the exponent. So we're going to distribute this exponent to everything. Now be careful, you need to distribute it to the 2/3 as well. A lot of students forget about that. So we have 2/3 squared, r squared squared. Now remember, when you raise an exponent to a power, we multiply the exponents. So r squared squared would be r to the 2 times 2, which is r to the 4th. Times s to the 7th squared would be s to the 7 times 2, which would be s to the 14th. Times 1/6 r cubed s. Okay. Next, we could actually square 2/3. 2/3 squared, we just square the numerator and denominator. We get 4/9. Now, we have r to the 4th. Let's actually do this in the next step. R to the 4th, s to the 14th, times 1/6 r to the 3rd times s. Okay, now we can multiply the numbers together. So 4/9 times 1/6. Now what you could do is actually clean this up a little bit, because 4 and 6 have a common factor of 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. So when we multiply across, 2 times 1 is 2, whoops, over 9 times 3 is 27. And then remember, we're multiplying r to the 4th times r cubed. We add the exponents. So we have r to the 4 plus 3 would be r to the 7th. S to the 14th times s. Think of this as s to the first power. We're going to add 14 and 1 to get s to the 15th. Sorry. Okay, and that is our final answer. It's a fully simplified monomial. Okay, we're going to do one more together that's a little complicated. Let's take a look at number 4. So this one has a negative exponent, and so we need to use the rule where in order to make a negative exponent positive, we take the reciprocal. So we can actually rewrite this as 7w cubed over 14w to the 12th, and that's now to the positive first power. Now, you don't really need that because anything to the first power is just itself. So I'm actually going to, erase that. Okay, well, from here, we can simplify. We're just dividing 7w cubed by 14w to the 12th. Okay, so 7 over 14, we can reduce that. These are both divisible by 7. So 7 divided by 7 is 1. 14 divided by 7 is 2. When you divide exponents with the same base, we subtract their exponents. So if you want to add that rule, x to the a over x to the b is x to the a minus b. That's the rule that we're going to use next. Okay, so we have 1 times, well, what's w cubed divided by w to the 12th? It would be w to the 3 minus 12, which would be w to the negative 9 over 2. No, I didn't do the 1 because it's 1 times. It's not going to look any different. Now, we don't like negative exponents left in our answer, so we're going to move that exponent, or the w to the negative 9, to the denominator, and it becomes positive. So we have 1 over 2w to the 9th power. And now it is fully simplified. I would also accept it. I guess we could do 1/2. I guess if it was a positive exponent, it would make more sense. I would just leave it like this. Okay, so go ahead and pause here and do problems 2, 5, and 6. And then once you're done with those, go ahead and unpause and I will quickly go through those. Okay, so let's take a look at number 2. We're going to go ahead and square that negative 2a cubed b first. Be careful to square everything. Negative 2 parentheses squared. A cubed squared is a to the, we multiply, 3 times 2 is 6, and then b squared, times 8ab to the 9th. Negative 2 squared is 4. We have a to the 6th, b squared, times 8ab to the 9th. Now we multiply the numbers together. 8 times 4 is 32. A to the 6th, b squared, times ab to the 9th. And we can go ahead and multiply those variables. So we end up with 32. A to the 6th, remember this is really an a to the 1st, 6 plus 1 is a to the 7th. B to the 9 plus 2, we get 11. And that is our final answer. All right, number 5, we are dividing. So what we're going to do is we have 15 and 24. Those do in fact have a common factor of 3. So 15 divided by 3 is 5. 24 divided by 3 is 8. And then we can subtract, right, our exponents. So we have 5/8. X to the 10th, we're going to subtract 12, would be x to the negative 2nd. And then we have y to the 4th minus 3 is just y. Now remember, we don't like to leave negative exponents in our answer, so we want to move that x to the negative 2nd down. So we end up with 5y over 8x squared. And that would be our final answer. Okay, last one, number 6. We have c over c squared to the 4th times negative 3c to the 4th. Okay, what I'd actually recommend doing is you can simplify the inside first. So we have c over c squared, which actually simplifies to c to the negative 1st, or 1 over c, and then that's being raised to the 4th. Oops. Times, let's go ahead and distribute that exponent. So it's negative 3 to the 4th times c to the 4th. So then once again, we can distribute this exponent. 1 to the 4th is still 1 over c to the 4th times -3 to the fourth, -3 times -3 times -3 times -3 is 81 c to the fourth. So we end up with 81 c to the fourth over c to the fourth. Well, anything divided by itself is 1. These kind of like cancel to 1. So we're actually just left with a final answer of 81 here. And this is still a monomial. Okay, let's go ahead and we're going to jump into polynomials now. So basically, if you take a bunch of monomials and you add them up, you get a polynomial. The highest exponent of a polynomial is called its degree. And the standard form of a polynomial, basically, we go from highest degree to lowest degree. So it would look something like this. You'd have a polynomial p of x, where it's a times x to the nth power, where n is the biggest exponent, plus b times x to the n minus 1, 1 less than that, plus c times x to the n minus 2, plus we can just say dot, 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 because we don't know how many terms it has. D times x plus e would be the constant term, and that would be at the end. Okay, so it seems a lot more complicated than it is. Really, all we're doing is we're locating in number 7, for example, the term that has the highest degree. So we have -k to the 5th minus 1 plus 8k minus 3k cubed plus 1/4 k squared. Well, the term with the largest degree is -k to the 5th, so that one's going to go first. Now notice the negative is attached to the k to the 5th, so it has to be together. Okay, next largest exponent would be that minus 3k cubed, so that's going to go next. Notice the minus stays with it. The next one would be k squared, so plus 1/4 k squared. Then we have plus 8k. And then we have minus 1 would be the term with the lowest degree. So you're just reordering the terms in order from largest degree to smallest. All right, go ahead and pause here and go ahead and do 8 and 9, and then you can unpause and we'll do those together. Okay, so for number 8, we're going to start with the term with the largest degree, which is a to the 6th, it looks like. So we have 5a to the 6th. The next one would be plus 102a to the 4th. Then we have plus 3a cubed, and then plus 18a would be last. There's no constant term in this, but it's still a polynomial. Okay, next we have a minus y to the 4th. Make sure your first term still has the negative y to the 4th in front. And then we have a 9y cubed plus a 5y squared, and then plus 2. Always double check that you didn't miss a term. So I have 1, 2, 3, 4 terms, and I still have 4 terms in standard form. It's really easy to accidentally miss a term or forget to write one down. Okay, so next what we're going to do is look a little bit into classifying polynomials, which is basically just looking at what we call the polynomials. Okay, so if a polynomial is degree 0, that is called a constant polynomial. If the largest degree is degree 1, we call that linear. Think about like x to the first, 2x plus 3, right, is the equation of a line. If we have a degree 2, which is x squared plus bx plus c, whatever it is. We dealt with a lot of those last semester in last unit, so that's called a quadratic. If it's degree 3, it's called a cubic. If it's degree 4, it's called a quartic. And if it's degree 5, it's called a quintic. Okay, the number of terms also tells us or gives us an additional name to call it. So if it has 1 term, it's a monomial. If it has two terms, it is a binomial. Three terms is a trinomial. And four or more terms, we actually just call it a polynomial. There's no special name for four or more terms. So we put the degree of the polynomial as well as the number of terms to give it its final name. So we're going to name or classify each of these polynomials in 10 through 17. So let's take a look at number 10. We have negative 3x plus 1. Technically, this is x to the first power. So if this is degree 1, it is a linear. Now it has two terms, the negative 3x and the 1. So it's a linear binomial. So you want both of those words in there because it's fully describing the polynomial. Okay, go ahead and take a moment, pause here, try numbers 11 through 17, and then you can unpause and we'll go through them together. Okay, number 11, we have a fifth degree, which is a quintic. And we have three terms, so it is a quintic trinomial. All right, 24, it's lonely. It's also technically degree 0 because it's x to the 0th power, which is 1, right? So this is actually a constant. And because it's only one lonely term, it's a constant monomial. Okay, next one, it looks like we have degree 3, so this is a cubic. And it has four terms, so it's a cubic polynomial. Okay, the next one, it's degree 2, so this is a quadratic. And it has three terms, so it's a trinomial. Okay, the next one is fourth degree, which is a quartic. And it's just alone, so it's a monomial. All right, this one says, give an example of a cubic binomial. Yours might look different than mine, that's okay. So its largest degree should be 3. So I could do 5x to the third, but it's a binomial, so we need another term. So I could do plus 1, right? Now it's a cubic binomial. Number 17, give an example of a linear monomial. Well, it's only one term, and we just want it to be x to the first. So I could do negative 7x, right? That is a linear monomial. Okay, so the next thing that we're going to be doing is learning how to add and subtract polynomials. And it's really not too bad. All you're doing is combining like terms. So any term that has matching degrees, you can combine together. The only thing you need to be careful of is if you're subtracting, you need to distribute over the parentheses. So be really careful with that. All right, let's take a look at number 18. We have 3x squared plus 11x plus 4, and we're adding negative 5x plus x squared minus 13. So we can combine our x squared terms. 3x squared plus 1x squared is 4x squared. Plus, we have 11x minus 5x, right? So we have plus, well, it's plus a negative 5x, right? So we have plus 6x. And then we have 4 plus negative 13. So 4, think of it as minus 13. We have a minus 9. Okay, and that's it. So we combined all of our like terms. We combined our x's together, combined our constants together. So nothing too crazy. All right, let's look at one with subtraction. So let's look at number 20. We want to go ahead and distribute the negative sign. So we end up with 5k cubed minus 2k squared plus 2k minus 2k squared minus 2k minus 17. Be careful. There's nothing to combine that cubed with. So that one I'm just going to write first. Oh, notice I'm writing my answers in standard form. So you want to make sure that it is written from highest degree to lowest. That's kind of why I'm adding and subtracting in that order. So we have 5k cubed minus 2k squared, and then I see another minus 2k squared. That would be minus 4k squared. We have a plus 2k and a minus 2k. That's 0. So those guys cancel. Whoops. And then just a minus 17. And this would be our final answer for this one. Okay, go ahead and do numbers 19, 21, and 22. I'm not going to go through these all because they're pretty redundant. So go ahead if you want to check your work for 19, 21, and 22. Go ahead and go to my website, mrsfitzmath.com, and they will be there. Okay, let's jump into multiplying polynomials. So let's start with multiplication first. And then we're going to get to ones that have a little bit more involved, that maybe have some addition and subtraction involved as well. So essentially, when we are multiplying polynomials, we have to distribute. Then once you distribute everything through, we combine like terms. So we're going to go ahead and start with number 23. You want to start by distributing the W to all three of these terms. We're basically foiling, right? So W times W squared is W to the third. W times 2W is a positive 2W squared. W times 1 is a plus W. Now we also want to distribute the negative 7 to everything. So we end up with minus 7W squared minus 7 times 2 is 14W, and then negative 7 times 1 is minus 7. And then from there we can combine like terms. There's nothing to combine that W cubed with, so that's alone. And then we have a 2W squared and a negative 7W squared. So we have minus 5W squared. Then we have a W minus 14W, which is negative 13W, and then that minus 7. It's not too bad, just lots of foiling. Okay, let's look at number 24. We got a lot going on here. So number 24, we need to foil all the multiplication before we can handle this subtraction. But there's one thing you really need to be careful about. Okay, so we have a binomial here, 2x plus 1 times 4 minus 9x. We want to foil. So first, 2x times 4, we get 8x. Outside, 2x times negative 9x is minus 18x squared. Then inside, 1 times 4 is 4. And then last, 1 times negative 9x is minus 9x. Now you want to distribute this 2x to both of these, but be careful, it's a minus 2x. So we get minus 2 times 3 is 6, x times x is x squared. Minus 2x times 11 is 22x. And then from here, we're just combining like terms. So it looks like our largest degree is x squared. So we have negative 18x squared minus 6x squared. So we have minus 24x squared. Then we have some x's to combine. So I have negative 8x, a positive 8x, and a minus 22x. Well, 8x minus 9x is negative x, minus 22x is minus 23x. And then it looks like the last term we have nothing to combine with, so it's just plus 4. All right, so that is how you do a problem like that. Okay, now let's actually jump to number 26. Number 26, be careful. You cannot distribute an exponent over addition. So we actually need to rewrite this as 2c plus 5d times 2c plus 5d times 2c plus 5d. All right, and we need to FOIL And we always multiply from left to right. So we're going to FOIL these first. So 2c times 2c is 4c squared. Outside, 2c times 5d is plus 10cd. Can't combine those, they're not the same variable. We have 5d times 2c, which is plus another 10cd. And then we have 5d times 5d, which is 25d squared. Now be careful, this needs to be in parentheses, times 2c plus 5d. We haven't handled that last factor yet. Before we multiply again, let's go ahead and combine like terms. So in here, I have 4c squared plus, those can be combined because they have the same variables. So this is 20cd plus 25d squared. And we're going to go ahead and multiply that with 2c plus 5d. And we got to FOIL all over again. Okay, so I like to distribute the binomial into the trinomial. It's just my preference. It's really up to you. So I'm going to distribute this in this way. So 2c times 4c squared would be 8c cubed. And then we're going to distribute the 2c to 20cd. 20 times 2 is 40c squared d. Okay. And then we have 25 times 2 is 50. And then that's cd squared. All right. We also need to distribute, I'm going to erase these so they don't get in the way, the 5d to everything as well. Lots of distributing here. So distribute the 5d. We have 5 times 4 is 20. C squared d, it looks like. And then 5 times 20 is 100. That is CD squared. And then the last one, 25 times 5. I barely have enough room. Let's see. We have 125. And it looks like D cubed. Okay, running out of room there. Okay, now we can see if we can combine anything. It looks like the only terms, we can combine this c squared d with that c squared d. So we have 8c cubed plus 40 plus 20 is 60 c squared d. We have 50 cd squared plus 100 cd squared. So that's plus 150 cd squared, and then plus 125 d cubed. And that is as clean as this one gets. That was a lot. Okay, so now go ahead and pause here, do numbers 25, and I don't know why that says 10. I think that should be 27, just a typo on there. But go ahead and do those two, and then check your work with my solutions on my website. All right, last section is on dividing polynomials. So we're basically taking a polynomial and we're going to divide it by a monomial. So be careful. When you divide over addition and subtraction, you have to distribute. So we are going to take 9m cubed and divide it by 3m minus 24m squared and also divide it by 3m. We distribute division over addition and subtraction. 9 divided by 3 is 3. M cubed divided by m is m squared. Minus 24 divided by 3 is 8. M squared divided by m is m. And that would be our final answer. So these aren't too bad. You just have to remember that you must distribute the division over the addition subtraction. Okay, let's try one more together. Let's look at number 30. Now this one, it looks like multiplication, but really it's going to be division because we're multiplying by 2ab to the negative first. And what we could do is move that into the denominator. So that way you're really dividing by 2ab. So it's 14a to the fourth b cubed minus 20a squared b squared plus 2ab all over 2ab. Now we want to distribute the 2ab to everything. So 14a to the fourth b cubed divided by 2ab minus 20a squared b squared divided by 2ab plus 2ab divided by 2ab. The 2ab's do not cancel and then you're done. Please don't do that. Everyone tries to do that. It is an illegal math move. We cannot cancel over addition and subtraction. We can distribute over addition and subtraction. Okay, let's go ahead and simplify. So 14 divided by 2 is 7. A to the fourth divided by a is a cubed. B cubed divided by b is b squared. Minus 20 divided by 2 is 10. A squared divided by a is a. B squared divided by b is b. Plus, now, anything divided by itself is 1. 2ab divided by 2ab is just 1. And so this would be our final answer. Okay, so go ahead and do numbers 29 and 31. I will have the solutions to these once again on my website. Go ahead and check your work for those two. And that is it for today. Thank you.